Hi, Sichaba. We'll just wait 5 minutes to see who else joins us and then we'll start, okay? We're going to do some of last week's lecture. If you didn't know, I was sick. I have COVID since last week, Monday. So that's why I couldn't attend the lectures last week. So we'll do one of the lectures that builds on today's lecture today. And the other lecture and the first lecture for today will be online. Okay, so any of the lectures that I did miss, it will be an online lecture that will be on Call Campus, and then also our regular online lectures. So let's just wait 5 minutes to see who else joins us. Guys, we're just going to wait a few minutes to see who else joins us. We'll wait 1 more minute. I can't believe there's only 4 students in the class. I'm really upset about the numbers in the online classes, really. Alrighty, guys, let's get started. So like I said, I'm going to go through one part of last week's lecture, which was the second lecture for last week, because I am ill. I was ill and I still am. I had COVID. I have COVID. So let's do the first one, which will be the first part of Excel, so you guys can understand it. Okay, So let me just put my slideshow. There we go. Right. So this is lesson 22. And we are on Microsoft Excel. In today's lecture, we will use math functions in Microsoft Excel. We'll do basic calculations, and we'll also apply some other skills that we know from our computer skills classes, which you do have computer skills. Okay, so for this lecture, pages 346 to 350 of Anderson et al. In the textbook. So now, what is Microsoft Excel? Microsoft Excel is a software program that can be used to calculate or recalculate, record, and plan numbers and statistics for various reasons. The program can also be used to represent data in graph or table formats. And in this lecture, we're going to be looking at some of the basic Excel functions and calculations. So what does a Microsoft Excel sheet or workbook look like? So in a Microsoft Excel workbook, you can create worksheets. Okay, I'm going to show you now. In every worksheet, there are many rows and columns. Each block is called a cell, and it's useful to think about each cell as an individual calculator. So here we have it here. You see at the top there, it says book 1. Okay, there, book 1. So this entire thing is a book. And here at the bottom, we can create different sheets. So here's sheet 1, and we can name these sheets. So if we click into this, we can delete the name sheet 1, and we can put, for example, November 2021, and we click on the plus sign here, and that can be December 2021, and then we continue in that way. So it's useful because we can have different months of a year in one single workbook. And in this way, we can do many different things. For example, we can do our taxes, we can do budgets, we can create different data and data sets of information with graphs, etc., in each of the worksheets. So the ones that are running across here, these are the columns, okay, and it runs from A to Z. And then the ones, right to left are the columns, and top to bottom are the rows. Any questions so far? Yes, Wanga?
Good morning, first of all, ma'am. So I had a bit of a conundrum. I used the 1020 link to kind of like join the class, and it wasn't working, only to find out that we were using the first link. So I kind of missed what you were saying.
No, I just started now. This is a 1020.
Oh, all right.
Yeah, I just started now. Okay, so what I basically just said, this is what I said. Basically, this was the first part. Sorry, let me just remove this. So this here was the first part that I said. This was the first part that I said. Okay, so like I said, this is last week's second lecture that I missed. And I'm just doing it for the benefit of you guys because I wasn't there last week. But there will also be a different online lecture for this. But I rather just explain it here because we'll have time. So yes, any questions about this? Book 1 or a column, a row, a sheet? Any questions? All right, you guys, remember, if you have no questions, to please write no questions in the chat so that I do know you have no questions. So in Excel, each cell you enter, you can enter a formula or calculation, okay? So basically in each one of these, you can do a separate calculation. When you enter a formula in a cell, Excel calculates the results of the formula and displays the result of the calculation in the cell. You can also link different formulas together from different cells to combine calculations. Okay, so Excel is a very smart program, okay? And it can do things very easily for you if you do know how to use it. So the easiest way to make use of a function in the cells is as follows. So here we're going to do mathematical calculations. Whenever we want to do a calculation in Excel, we enter the equal to sign first. It's the first thing you should do when you want to do a calculation. Okay, so you enter the equal to sign. Now the cell recognizes that you want to enter a formula into it. Okay, it knows, okay, this is going to be a mathematical sum. So because I have the equal sign. And then you type in your sum and you press enter. So for example, if you wanted to calculate an addition sum in a cell, such as 5 plus 2, you would press equal to and then type in the sum as is and press enter, and the answer 7 would then appear in the cell. So we can apply this process in all kinds of operations. So as you see there in the example in cell A1, we put the equal to sign, and then we did an addition sum, and then Excel will calculate it for us, and then we get the answer of 7. Any questions about this? And as I said, I'm repeating, when we want to do calculations, we always start with the equal to sign. Okay, let's continue. Okay, so in Excel, you need to use the following symbols when doing basic operations. You use addition, subtraction, multiplication, and division. Okay, so for any kind of sum that you want to do, you use the following signs. Any questions? Okay, let's continue. So sometimes in Excel, it will show you a warning, okay? Especially if you are inputting the incorrect information, or when it doesn't recognize what you're writing because it's not a format that Excel recognizes, okay? So the program will usually indicate what you did wrong, okay? So there'll be like a pop-up box and it says, this is incorrect, or that is incorrect. Sometimes Excel can be quite difficult to understand if you don't understand the functions and how they work. Okay, so when doing calculations, you may want to use the data or results you have already typed in other cells of the worksheet. Actually, maybe I should just show you like an error in Excel quickly before I continue. So let me open up my Excel here. Right. So for example, let me open a new tab here. If I do, let's say 7 plus 8, and then let's say equals to okay, it's not going to work, but A1 plus 8, let's see, 84, this 84, it's going to give me an error. Okay, so here we go. You see, this is an error message. So there are one or more circular references where a formula refers to its own cell either directly or indirectly. This might cause them to calculate incorrectly, okay? So it's gonna show some kind of message. It will give you incorrect, a pop-up message to show you what you are doing correctly and or incorrectly. Okay, let's continue. So when doing calculations, you may want to use the data or results you have already typed into the other cells of the worksheet. In Excel, data in other cells of the worksheet can be linked to your new formula in another cell. Excel will automatically update the calculation if the information in the linked cell changes. Okay, so what this means is, I'm going to show you how we do it here instead of going through the explanation. This makes it easier to understand. Now in Excel, we can use different cells to do a calculation. So we can take a cell, we can see here it says B1. Okay, so we see B1, and then we want to add B2, so plus B2. So we want to add these two together, and then we perform the calculation as such. So we put the equal to sign, the cell number plus the other cell number. And then obviously, if you would want to do it in any other way, you can do that as well. And by the way, we also use board mass in Microsoft Excel as well. But this is just very simplified how we use it. And now if we had to update B1 or B2, so say, for example, your initial calculation was 10 for B1, and then you updated it because you got some new information to maybe 25. So when you update cell B1, the answer in A1 is automatically going to update. Okay, so that's why it's a very smart software to use. Any questions? Okay. So in addition to the basic operations you can perform in Excel, there are also many other and more complicated operations you can perform with pre-programmed functions in Excel. So Excel has lots of cool functions that you can use mathematically. And I was telling the other students as well, if you know Microsoft Excel, it's so easy to get a job because it's so used in every type of industry and business. So the functions, some of them include adding the totals, averages, percentages, and other financial specific functions. And we can do cell calculations in the worksheets. So you can experiment with Microsoft Excel to understand how we can use these functions more effectively. So for example, here, you'll see the function button. If I had to go to mine, over here, you'll see it here, function, and then it's going to give you a list of all the functions that you can use. It has, I think, hundreds and hundreds, and I'm not even sure about all of them. I only know the most important ones, which is date, sum, average, count, max, etc. And there's minimum as well. Okay, but you can add literally hundreds of functions into Microsoft Excel. Okay, so you can experiment around with it to see how you use it. And you can do all kinds of calculations with it. Any questions? Alrighty, so guys, let's go on to today's lecture. So today's lecture is a little bit more intense as we're building up from the previous lecture. So we're continuing with Microsoft Excel. We are on part 5 of 6. Okay. So far, are there any questions about Microsoft Excel that I've shown you so far? Alrighty. So it is useful to try the calculations to see how you do them so you can get experience with how to use Microsoft Excel. So we are on pages 350 to 364 of chapter 10. Okay, so basic graphs and tables. So once data has been collected, it needs to be organized and summarized for easy interpretation. Okay. So this can be done in many ways. Data is often initially organized into frequency or tally tables, which different types of graphs are used to represent these frequency or tally totals during the data collection. These graphs are then used during the data analysis process. And in this section, we will look at the types of tables and graphs available to represent these calculations. Okay, so firstly, we have to collect data. Okay, so how do we get data and how do we represent data? So data is often collected through surveys or questionnaires, especially when companies do market research. There is constantly a need to calculate and count survey or questionnaire totals. Many other types of research also require recording numbers in an easily understandable and accessible manner. Frequency and tally tables are therefore used for this purpose. So has anybody used a frequency or a tally table before? Okay, you have, some of you have, okay. So for example, say you want to represent the number of students in each academic year at a specific university in graph or table form. So there are 1,675 first year students, 1,600 second year students, and 1,234 third year students. We can represent these totals in a table, or more specifically in a frequency table. So here we go, here's the frequency table. So it's the rate at which something occurs. So we see at the top, it says here at university and then number of students. So the first year, 1,675, second year, 1,600, and the third year, 1,234. Okay, so basically this is how we represent, or we get data and then we can put it in a table format. Questions? Okay, so what is a tally table? So when representing the total number of answers to simple yes/no questionnaires, we can use a tally table. A tally table helps you count respondents' answers by indicating each answer with a mark. To make counting easier, the tallies are grouped in fives, with the fifth item being represented as a line, as crossing out the other four tallies. So I didn't do it specifically like this, but it can be done like this. We can use a tally table to calculate the total number of answers in a questionnaire as follows. Okay, so here we see a tally table, okay, and it shows us the number of respondents, the answer that they indicated, and the total. Questions? Okay, let's continue. So now once the data has been tabulated and recorded in tables and other formats, we can display the data and what the data means in reports. So these reports usually use graphs to display the data, and there are different types of graphs and visual representations of data, depending on what is being asked for us or what is the best way to represent the data. So certain graphs are better suited to represent certain kinds of information. And the following is a list of the most commonly used graphs, which we're going to see how to do today. So we get pictographs, double bar graphs, pie charts, histograms, bar graphs, and line graphs. Questions? So right now we are on page, let me just get the page number 352. And actually, this is supposed to say pictograph, not pictogram. Okay, right. So Pictographs are images used to represent numerical data, and each image represents a certain number of items in the figure below. Each image of a person represents 5 students who attend a tutorial. By representing the number of students in this way, data is condensed. Okay, so we can say here, I was just putting it here just for purposes of representation. But for example, we can say one of these figures that I have here, or one of these pictures can be 5 students or 6 students. Okay, and then we would get the number of 20. So we can say 1 student equals 5 or 6 students, 7 students, 10 students, whatever. Okay, and then we can say this can be the day of the week, the number of students, and then we would have a total at the end of each day. Any question about a pictograph? Okay, let's continue. So pie charts are good in representing different variables in proportion to one another. So has anybody used a pie chart before in any of their calculations or anything else? Yes, great, fantastic. So what did you use a pie chart for? Anyone? Good, excellent, Bukeka, for segmenting data. Excellent. So pie charts are good in representing different variables in proportion to one another. The different slices or segments of the pie show how the whole consists of different parts, so i.e. percentages of a whole. So I did mine a little bit differently. I don't know why I put days of the week instead of smartphone, tablet, Kindle, and PC. But anyway, here we can see how a pie chart is broken down into different parts, depending on the denomination that is used. So I just want to show you here in Excel how we do it. So let me just get out of this if I can. Okay, so here we go. Here's the pie chart. So I want to draw your attention to how we put the data in firstly, and then how we get the pie chart. So for example, we would have, you can see in the textbook there, it says smartphone, tablet, Kindle, PC. Okay, so we can put that down here. We can write smartphone, and then we do it down here. So it will be here. Okay, I don't know why it's not inputting my data anyway. So let me just delete this. I wasn't meant to delete it completely. Okay, wait. Don't save. Okay, so let me just open that up again. Okay, I'll just do this basically. So anyway, guys, you will list that down here. So it will be smartphone, tablet, Kindle, PC, and then you will put the percentages next to it. And then you're going to highlight the data like this, and you'll go to insert and you'll say recommended charts. Okay, or you can go down here where it says pie chart and do it in any which way that you'd like, but it's better to come here, and then we'll get this kind of chart, which is the pie chart with the different segments of the different students' use of electronic devices or each day of the week and percentages, etc. Any questions about a pie chart? And please have a look at how I listed the data here. Okay, let's continue. So bar graphs. Okay, what is a bar graph? Anyone want to guess? Guys, I feel like I'm talking to myself, hey? And I like literally hate that. That's like the bane of my existence in all of my teaching and instructing. Does anyone want to guess? Okay, good. Excellent, fantastic, Sal. So bar graphs are used when you want to compare information. So the data is represented by the horizontal axis, horizontal or vertical bars that differ in height according to the value. So they don't necessarily have to differ, but yes, when we show different percentages of values, rather, they will differ. So in the figure below, the bar graph's vertical axis is on the y-axis, shows the number of students, while the horizontal axis shows the days of the week. And it can be seen that the day with the highest attendance of students was Monday, with 50 students in attendance, while the most poorly attended day was Friday, with 30 students in attendance. So here we go. Okay, so yeah, I didn't exactly, I must change some of my graphs and update them actually, because I didn't give them any labels. But here, I think I did it here with the bar graph. You can see it here. It says attendance figures Monday to Friday, and then we have the days of the week and the number of people. So the number of people on the y-axis and the days of the week on the x-axis. And at the top, we have the chart title. And you can see I've numbered it quite nicely. So I have 50, 40, I think that's 45, 45, and then Friday with 30. And then we can compare which day the students attended the most. Any questions? Question about a bar graph? No? Okay. So now we get to a double bar graph. So double bar graphs allow you to compare two sets of data against the same criteria. So the double bar graph in the figure below compares the marks in percentage of two students across 4 academic terms. So it can be seen that student B consistently performed better academically than student A across all 4 terms. So here we are comparing 2 students and their results. Okay, we can see student A, student B, and then we get 0 to 100 on the y-axis, and then we have the terms on the x-axis, and then the chart title. So let's have a look at how we do it in Excel. So here we go. Notice how I input the information into Excel. Okay, so I have term 1, term 2, term 3, term 4, student A, student B, and then it gives us a comparison. Once again, we'll go into insert, recommended chart, and it's going to give us these details, and we can choose which chart we want to best represent the data. This would be the best way so that we can see a clear comparison between the two. Any questions? Okay, so now we're going to get to a histogram. So histograms also allow you to compare sets of data. The difference between a bar graph and a histogram is that one axis in a histogram represents continuous intervals, such as increasing numbers, which means there will be no spaces between the bars. Most often this occurs on the x-axis, seeing as it represents a continuous data range. Often the bars in a histogram also represent intervals or classes into which data has been grouped. We group data into classes to make it easier to represent the data on a graph. Okay, so we can see on page 355 an example of a histogram. Okay, so I had a little trouble with this, with putting the data into specific intervals. Okay, so this is something that I still need to learn how to do. But I did create the histogram, but it didn't have the correct intervals like it was here. So between 0 and 20, 21 to 40, etc. When I created the histogram, it gave me these intervals already. Okay, so I must still find out how I change the intervals on the X and the Y axis accordingly. I'm not too sure about how to do that in Excel yet. Okay, but we can create a histogram. Okay, so all we have to do is go to the data. Please notice how I input the scores. Okay, so here we have all the students that we're looking at. I put in their values here. I highlight the cells. So let's highlight here. Okay, and then we're going to come down here, and I think we're going to have to choose because it's not going to give it to us as a recommended. So if I go here, recommended, it doesn't give it to me as a histogram. So I have to come and see and find where I get a histogram. Okay, so here we go. Here's the histogram over here. And then I'll click on histogram and it's going to give me the information accordingly. Okay, so when I think if I just went to here and I went to chart design, I'm not sure if here, actually it wouldn't be here where I can change the data. So I must still find out about the X and the Y values and how to change them accordingly. I'm not too sure about that, but this is the way that you would create a histogram. Any questions or comments? Right. Okay, let's continue. So guys, the next one will be vitally important because we're talking about the line graph. So line graphs or line charts are used to show data that change continuously over time. These graphs are useful in highlighting data trends and changes, which in turn can help you notice and provide commentary on emerging patterns. Who wants to tell me what's a data trend or change? Or you can guess. Okay, guys, I want to give you the link for the second meeting. Here. Okay, here we go. Shiga, you can tell me in the next meeting. Shiga, I'm going to send you the group 3 information, right? I'll send it to you in email. Just stay in today's lecture with us. Right, so guys, going to the second meeting and I'll meet you there. Tapiso, are you leaving to go to the second lecture? Let's just wait a few minutes for people to join us and then we'll continue. Also, we might go into the third lecture today. So let me just give you the link for the third lecture so you guys have it. Okay, so I'm going to put it in the chat. So guys, please take note of the third lecture meeting in case we do run into the third lecture today. All right, I think I can get started now. Okay, cool. I don't know why my computer is doing this all of a sudden. It's really strange. So line graphs are used to show data that change continuously over time. And these are useful for highlighting data trends and changes, which in turn can help you notice and provide commentary on emerging patterns. Yes, somebody was telling me what is a data trend. Please rewrite that sentence in the chat for me, or you can open up your mic to answer. Anyone?
Ma'am?
Yeah. Yes.
Isn't it when something that just rapidly changed or something that just increased?
Okay, that's a good try. So basically what a trend shows is how something changes over time. Okay, so for example, we'll have month 1, 2, 3, 4, 5, 6, 7, 8, and then until 12 or whatever, etc. And then we'll see the change over time. So there can be an increase or a decrease, okay? And when we refer to this, we call it a trend. So when we talk about trends, we can see many different things. For example, that's how they look at global warming. They look at the data changes in the temperatures, the data changes in the melting of the ice caps, okay? So these certain things show us the changes over time. Yes, exactly. So trends always occur over time, okay? And then we can look at the pattern of change in this way. So for example, in your assessment, they ask you to do a line graph and then you can see the change of whatever's occurring. Okay, good, Lebohang. Excellent and great, great answer from you there, Sal. That's a very good try. So in the figure below, we see the line graph for student A's marks in percentage over a year. And you can see that student A's marks dropped slightly in term 2, but then improved throughout the year. So here we go. Here we can see, here's our line graph. It's called student, we gave it a nice title at the top, student A's academic performance in 2017. And here we see on the x-axis, term 1, term 2, term 3, term 4. The y-axis, we have percentages from 0 to 90. Okay. And yes, I still need to figure out about how to put in the values on the y-axis, actually, because it should actually run through 100. Excel does this automatically. When I get more information about that, I will let you know. Okay, hopefully by the end of the day, so tomorrow, I can give you feedback about that. But let's look at how we do the line graph in Excel. Okay, so here we see the line graph, okay, and then we see here term 1, term 2, term 3, term 4, and then we have the percentage. So guys, look at how exactly I input the information into Excel when I wanted to create the line graph, okay? So then what I would do is I would come here, okay? Every step that we take in Excel to create a graph or a chart is the same. The way we input the information is different, as you can see, just showing you guys, okay? And here's the line graph, and then we'll go insert and then recommended chart, and it's going to give us this here. Okay, when we click into this, if I click here, then I can click into this and change the title. Also, I didn't put any X or Y values here, but I'm going to show you guys how to do that and how to put labels for the X and the Y axis as well, axes. Any questions about the line graph? Because this is what you're going to do for your assessment. Any questions, guys? Alrighty. So let's continue then. So the type of graph you choose is dependent on the aspects of the available or collected data you want to highlight. You should carefully consider which type of graph to use to ensure that your information is displayed in the most accessible and easily understandable way. So usually in the workplace, they will tell you what kind of graph or chart that they're looking for. In academia as well, they're going to tell you what is asked. Sometimes especially where I am at WITS, they don't tell you, so you're going to have to represent the data in the best way you see fit, okay? And then you got to use critical thinking, which is necessary. So once you have collected the data, all the required data for a research project, your data will be disorganized, and this is referred to as raw data. Raw data needs to be organized in order to represent it via different types of graphs. Once we've properly organized it, we can display it via appropriate graphs and use the data as descriptive statistics, which will communicate meaning to readers. The first step in organizing raw data is to tabulate the information into either frequency or tally tables. Frequency tables often use tallies to organize raw data. Okay, so exactly like what I've been showing you recently in the Excel sheets, that's what we would do to input the data into Excel. So the raw data represented in the tally table, which we looked at on page 351, consisted of a collection of answers to a question given by respondents in a survey. The researcher would have collected all the questionnaire distributed in the sample and then would have counted and transferred the number of yes, no, and unanswered responses into the tally table. The next step is translating information into easily understandable graphic representations, and it would be for the researcher to group the information in the frequency or tally tables into intervals or classes. Okay. So we need to group the information accordingly, correctly. So now the tally table that we see on page 351 does not require the creation of classes, as there are only 3 possible responses to the research question. This means that there are already 3 existing classes. However, the example of the histogram in the previous section illustrates a case where it is necessary to make intervals or classes from the collected data. So yes, when we saw the histogram on page 355, okay, here we can see they have intervals 0 to 20, 21 to 40, 41 to 60, 61 to 80, 81 to 100. So maybe I'm going to try to do that today and see if I get it right. I will group it, try to group it in those percentages and see if it comes out correctly. I was trying a lot with it, but I couldn't get it right. Okay, but so here we can see there's intervals or classes from the collected data, and the researcher grouped the various grades of students into grade intervals to minimize the number of values represented on the graph. So once the data is grouped, once the data is grouped into classes, it will be easier to see the class in which most of the respondents' answers or other data points fall. Any questions? Yes, Bukeka, for the assessment, you have to do the line graph. That's why I was asking if there's any questions about it. Okay, any other questions so far? Yes, Bukeka, in Excel. If you want me to go through the line graph again, I will. Right. So you can choose, excuse me, the most suitable type of graph on which to plot the group data to ensure the data is represented in a very accessible and easily understandable manner. Specific information can be then interpreted and obtained from the graphs, and conclusions about the trends and patterns highlighted on the graph can be described and analyzed. Right, so Bukeka wants me to go back to the line graph, so I'm going to go back to the line graph and show you guys. Okay, so let me go to the line graph here. Right, everybody, please pay attention to the line graph as we see it here and how it's plotted. So we see here, we have term 1, term 2, term 3, term 4, and then we have the percentages. Okay, then guys, it's really simple. We just highlight the data, okay, just the data. We don't need to, I can remove this percentage here and just highlight the data. And then I will go into insert and I will say recommended charts. And here it will give me the line chart. And then I'll just click into it and it will be added, as you can see. Now I have my chart. Okay, I want to show you everything like how it's supposed to be done, right? So guys, I have this, I can change this now. Now I can change this title, can go click into it and delete, and I can name it Student A's Academic Performance. Okay, I'm just going to do it for instructing purposes. All right. So now there's we have Student A's academic performance, but we notice now that we don't have any x-axis or y-axis or any information about that. So what do we do now? We come here to add chart elements and we see here it says axes, primary and vertical. And then we have axis titles. So I'll click onto primary horizontal, which will give me here, and I can name this. So I can say terms of the academic here if I want. Okay, and then I will go back to add chart element, and I would say primary vertical, and here it will give me this axis title, and I can change this and I can write percentage. Okay, so we see that we have a graph and we can enlarge it like this by dragging on the corners. I just want to move this graph. Okay. So it's better represented. We can make it larger, etc. We can even click into the font and change the font size so we can make it bigger. Okay, etc., etc. And the numbers bigger as well. We can change the position of the chart title depending on where we want it, etc. Okay, to make it more visually appealing, we can do the same here with this information. We can make it bigger. We can change the font size here as well. Any questions? Bukeka, are you okay now with this information? Oh, yes, of course. So guys, this is, I was going to show you this earlier, but I'll show it to you here now. You click on the chart and you say copy. All right, you copy it. And then you go to your Word document. Okay, I see I was showing the other class here. Let me delete this one. So I want to delete this. Right. So I'm going to paste, Control V. I paste, right? And then I'm going to click into it because I also want to make sure that I can move it around, because now as it stands, I can't move this. It's very difficult to move. So I will go here. I think it's format. Let me just find it again. Chart design. No. So click here. Okay. Click on the chart. And then it's going to say wrap text. Okay. So find the wrap text. You're going to wrap it tightly. Okay. So I'm going to wrap it tightly. And now I can move this chart wherever I want in my document. Okay, so maybe I've written question 1, and now I want to put this below question 1, and then I've wrapped it tightly so I can move it around anyway. Okay, so basically you're just going to Control C to copy, and then you're going to Control V, and then you're going to wrap this tightly to move it around in your document. Okay, any questions about that? All right, so let's continue. Right, so I was here. Okay. So when reading graphs, we must realize that they often show relationships between two variables or sets of information. So the horizontal axis represents one set of data, and the vertical axis represents another set of data. Okay, so in this way, when we read from the graph, for example, here we're talking about temperatures and the months, we can see what each percentage was for each month in each particular place, and we can note trends and patterns in the changes in the temperature. Sorry about the slide, it's a little bit bad in the spelling. So for research purposes, it is therefore important to correctly draw and put values on the axes and to ensure this collected information is displayed accurately. Okay, so sometimes people choose graphs that do not best suit the data that they would like to represent, and this can result in graphs that look misleading. Incorrect drawing and compilation of graphs can also more easily result in errors in the display of data, and therefore misrepresent the data a person aims to show. Okay, so guys, when we are looking at a graph, in no matter what context, no matter what exercise we are doing, maths, calculations, Excel, okay, we need to make sure that we look at the information that is given to us in the graph, and we need to evaluate, okay, and see if it is a correct representation of the data that it attempts to depict. So here we're going to look at 2 examples, okay, that graphs displaying the same information in different ways. Okay, so let's go to the examples. We're going to look at 2 bar graphs. So here we can see bar graphs of using intervals of 10%. Okay, so comparison of marks of student A and student B, and we see 0 to 100. Okay, and then we have intervals of 20. So it's the same information, but we have intervals of 20 on the y-axis. Okay, so this can be maybe a little bit misleading for the person who is reading the graph, basically because of the axis that was used. So now we can see here that why it can be misleading is that you can see that the difference of the axes creates some kind of a confusion, and maybe it's a little bit more difficult to read. Okay, and while the first graph displays the data in a less ambiguous manner, you should always look carefully at the intervals and labels of axes, as well as the titles of the graphs, in order to ensure you understand what they're representing and what is the reflection of the data depicted. Okay, so make sure that you understand and you don't get confused because it can be confusing. Where any questions? Alrighty. So when drawing graphs, either by hand or using software such as Microsoft Excel, one has to ensure that certain essential features are included. Certain parts of a graph are always labeled, okay? So ensure that they are always labeled and that it is clear what information of the graph is displaying. Look at the vertical bar graph in the figure below to see what should be labeled on a graph. Okay, so I did show you some of the labelings that I included. So I put the x-axis title, the y-axis title, and the chart title as well. Are there any questions about that? So maybe this is not such a good example to show you. I should show you here, not here, sorry, in my Excel. So here. I think I did it exactly like the way they did it in the, yeah, I did it exactly there, like this. Okay, but here I did put the x-axis and the y-axis as well. Okay, so if we go back here, okay, let's look, and that's an example of a correctly, this is actually an example, this one here. Okay, where we have the chart title, the y-axis title, okay, the x-axis title. Sometimes we can add more information depending on that chart design here. When we add the chart elements, you can add different things when you go to this. Okay, so note that the following features of a graph are always labeled: the graph title, which describes the graph, what the graph represents, the x horizontal title, which represents the independent variables, and the y-axis, which represents the dependent variables. Okay. The additional key on some graphs, such as indicated by the label series 1, which illustrates further information, such as exceptions or notes about the data. When creating graphs, it is important to remember that the intersection of the x-axis and the y-axis always represents the value 0. So where the x-axis and the y-axis meet, it's a value of 0, which means in most cases it will be, where will it be? Who wants to tell me where it will be? Where do they meet? Good, Bukeka, at the intersection. So we see the intersection is at the bottom left where it says 0. Okay, so here the x will be 0 and the y will be 0 as well. Okay. Any questions? Guys, I just want to stress to you that Excel is one of the key programs that are used in businesses, okay? If you know Excel and you know it well, you will definitely get some kind of employment because they use it, or its use is quite widespread across businesses, okay? So it's good to understand it, okay? So also the first interval from 0 to the next value cannot be greater than the recurring intervals continuing on the axis. as this would result in a misleading display of data. Okay, so yes, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Most graphs these days are generated using computer software such as Microsoft Excel, as these programs can automatically generate graphs from frequency tables. These programs also offer a variety of graph tables which can be used to display data in meaningful ways. As we've said earlier at the beginning, Microsoft Excel is a computer program that can be used to calculate basic maths operations and formulas in spreadsheets, and it can be used to produce professional looking graphs in spreadsheets using the data you have entered into cells. For example, you may have used a spreadsheet to create a frequency table. This recorded data can then be translated and displayed into the choice of graph that best represents the collected data. So guys, how do we go about creating a graph in Microsoft Excel? I'm going to show you, please pay attention, but I basically did show you the steps when I was showing you the different graphs. Okay, it's not too difficult. And I'm hoping that whoever the 8 people in this lecture today are going to get it right when we do it for the assessment. Right. So step 1, you enter the data you have collected or researched into a spreadsheet. The information that appears in columns will be vertical on the graph, and the information that appears in the rows will be horizontal on the graph. Okay, the figure below shows the data entry for the attendance figures of an event. So here I put my own because I couldn't exactly see what was going on in the textbook. But like I showed you today in the lecture, okay, we represent data differently accordingly, okay? Because if we do it in different ways, the graph might not come out correctly. So make sure that you review how I input the data in today's lecture for the different graphs if you want to create them. So here we go. I have term 1, term 2, term 3, term 4, student A, student B. Okay, so I input the data into my workbook. Any questions? Righty, so let's continue. Step 2. Once the entry of data is complete, you highlight the cells you want to display in a graph. It is best to only highlight the cells that contain the values that must be displayed on the X and the Y axes. Once the graph has been compiled by the program, chart titles and other information may be added to it. The following figure below shows the highlighted data, which is now ready for compilation into a graph. All right. So here we go. I've shown you, I've highlighted the information that I wanted displayed. So it has the green block around it. That means it's highlighted. Which steps trigger? The first step. Okay. So you enter the data you've collected or researched into a spreadsheet. The information that appears in columns will be vertical on the graph, and the information that is entered in rows will appear horizontally on the graph. Now, this actually just depends on the information that you're inputting. Like you saw in the different graphs, the different charts that I had, I displayed the information in different ways, and I wanted the graphs to look correct. Okay, so it does matter about how you input the information into the Excel sheet. So for example, if we look here, I did it differently for different ways. So that was the pie chart, that was the bar graph, that was the double bar graph, that was the histogram, and that's the line graph. Okay, so make sure that the way that you input the information is correct. Okay, because you want the data to be displayed correctly as well. Is that fine, Trigger? Alrighty. Okay. So step 2, then we're highlighting the information. Okay, it's highlighted. And then let's go to step 3. So on the menu bar, we'll select insert and then select the type of graph that best depicts the collected data. A large variety of graph types is available, and these types will appear on the tabs under the menu bar. We click on the desired graph type, after which the program will automatically compile the data into the chosen graph format. Okay, and the figure below shows an automatically generated bar graph, which was generated by Excel after a chosen graph type was selected. So here we go. So I'm just going to show you guys again in Excel what we do. So of course, I did show you here when we do the line graph, but I'm going to show you again here. Okay, we do this. We select the data. We go to insert, recommended charts, and then of course we get the charts that we are looking for. Okay, and then you can choose which one you want. And then you press enter, and then you're going to get that lovely picture over here. So it's going to say chart title. Okay, and it's going to give you these kind of values. Questions? Alrighty, let's continue. Okay, so once you have the bar graph that has been compiled, a chart tools tab will appear from which you can apply various editing options. For example, adding a graph title, titles for the axes, and other features to suit your preference. So I just want to make you guys aware, I work with a Mac computer, so it's a little bit different from a Windows system. Okay, so when you click, probably it's a little bit different with the chart tools. Okay, so you notice for me, I had to input the information. I'll show you, let me finish this and I'm going to show you guys. So you can change how the graph is formatted using the layout tab, which can also edit the data being represented in the graph. Okay, you should edit the graph in a way that will increase its ease of readability in a format that is simple and aesthetically suitable for its purpose. So the figure below shows the edited bar graph, which has been reformatted with added labels and features. So let me show you guys this. Okay, so see, I've added here, you can see here, I've added these markings as well. Okay, then I've added numbers here. And then that's the title, that's the x-axis, that's the y-axis. Okay, so let me just show you quickly. We're almost done with the lecture today, actually. Yeah. So I want to go here, all right? And then remember when I did this, and then it went here to chart design and format, and then you can get here, you see add chart element. I'm not sure if you can just, if somebody can just open Excel on their Windows computer and tell me if it's the same, because a Mac Excel is different. And then here I had to add the axes. I can add the chart title. Then it says above the chart, centered overlay. So if I do this, then it gives me the possibility to change where the chart title is. And then data labels, error bars, grid lines. Okay, so here we do that. You see we get extra grid lines to show. So you can play around with these things and see what happens if you add them or remove them. But we must have the chart title and the axis titles as well. Okay, we need them for us to see. We have to have them, and I'm showing you this here. Okay, so and then here we can even choose how we want it displayed. Okay, so we want it like this. Okay, and notice that I did actually put the percentages there. Okay, which makes it easier for us to understand. So what we'll do then in step 5 is that if we are happy with the final representation of the data, we can select the graph and copy and paste it into a report, presentation, or other document in another program. Okay, so then we see it here. Okay, look, I've made it bigger. I've increased the font so it's easier for the audience or the people reading it to understand. We've got the X and the Y labels. Okay, we've got it numbered there, etc., etc. Okay, we can display it in a way that we feel is best understood for the audience. Any questions? Alrighty, so guys, do we need to go into the third lecture for today? There's an activity on page 10B, which I do want you to do, but I know that in the online lectures, you guys really don't want to do the activities or you don't want to do the activities in general. Is there anyone that wants to stay and go into the third lecture and do activity 10B? Yes, I'm going to send you that email, Siga. I'm going to send it to you right now after this class finishes for the links for group 3. Trigger the same, if I give you the link, it's the same link for the Tuesday morning class and the Thursday class. Okay, so you can use it's the same exact link. All right, so guys, yes. I think in the next lecture, I'm going to go through the assessment. So if you have any questions about the assessment, please let me know. I know that you've got your marks. I hope that your marks were okay. We were very, very lenient with marking. Yes, Bukeka. Or at least I was.
Hi, ma'am. So, ma'am, in our assignment, the question that I have is when you read, I think it's the evidence requirements. Okay, but when you read somewhere in the assignment in the brief, it says that section A you're gonna submit online, but then section B is a test.
No, please just ignore that. I think there was some mistake with that. So you just, everything is going to be, you're going to upload it on Call Campus. Okay?
Oh,
Yeah.
all right, ma'am.
All right. So yeah, just come with your questions again in the next lecture. If there's anything you don't understand from the Excel, let me know. The next lecture, which is tomorrow, I think, is going to be a little bit complicated. Budgets are quite easy to understand, but when it comes to talking about compounding and simple interest, etc., it can be a little bit complicated to understand, but we're going to do it in the best way possible so you can understand it. It's also very useful when we do investing. I do a lot of investing. Well, not a lot, but I try to invest money, and we can make a lot of money just by investing money. Okay, so we're going to talk about that in the next lecture. If you need any help with anything, let me know. And these lectures will be up by the end of the day today. Okay, so I hope you learned a lot today in today's lecture. Any questions before I leave you? All righty. Okay, great, guys. So yes, see you tomorrow for an intense maths lecture. I look forward to seeing you all there and hopefully more students. Bye, everybody. Bye, Sechaba.